terms of connective tissue. At the end of the day, in a lab class, you're going to be looking into a microscope. We'll have tissue that has been cut and put on slides. And you have to tell us what class of connective tissue it is. You may also have to say like, oh, well, you would typically find this connective tissue in the whichever organ system, okay? So you need to know like a location. So this is areolar tissue. There's some stuff you should always really kind of notice when you're talking. There's like 3 things, look for 3 things in how they're organized. Fibers, okay? Most connective tissue has fibers. They hold it together, which makes it connective, right? They connect this tissue to other tissues also. The second thing is what the nuclei are doing. These little spots here, these are stained nuclei. That's where all the genes are, right? And then what the extracellular matrix or the open field looks like. In this one, it's very open field. So areolar, in this case, is something that's supposed to do a lot of cushioning. It wraps and envelops, but it's not too tight, right? So like white blood cells can still kind of get in and out of the area. Fluid can still kind of get in and out of the area in a lot of ways. So there's this. It holds reservoirs of fluids, extracellular, fluids. So we call these open areas where we're talking about like the fluid and all that cushioning, oftentimes like a ground type substance, right? I'm not going to really make you distinguish between collagen and elastic fibers too much like today, but know that that's who they are. Collagen is the strong one. It's like the rebar. And elastin is elastic. It allows for a bit of bounce. Okay? So that's their functionality together. It's called areolar because it's an areola, essentially. So it has a dark center with like a field that's lighter, a defined field that's lighter. That's like what an areolar phenotype looks like. Okay? So we'll find these. This is like surrounding stuff. This surrounds a lot of organs, for example, like packaging. Okay. This one's a little bit different. So this is fatty tissue. This is adipose, which we're learning now. Adipose is actually type of glandular, like it's regulatory. It has a lot of other functions besides just holding energy. And when we talk about holding energy, you see these big white circles? Those are fat or lipid droplets. So they store lipids, okay? We're learning more about what they do. We don't know a whole lot. Maybe, I don't know a whole lot yet. I'm sure the researchers do. So in here, these are nuclei, right? That makes sense. Those are the nuclei. In this case, we're not going to see a lot of, when I tell you to identify what the fibers are doing, there aren't fibers here. So you would identify as there are no fibers. I think this is one of the easier ones to identify. Typically found in conjunction with the dermis, the epidermis, like breast tissue, also in different individuals, like maybe it'll be around visceral organs as well. It comes in different types of colors, but we'll go ahead and move forward. I kind of love reticular tissue. So this is reticular tissue. So like when you have, say, filtering type organs, for example, like here's a spleen, right? It's spleen. And it just mainly is warehousing a lot of, vasculature and a few lymphatics, but like really, it has a lot of cells that are like secreting or filtering or producing enzymes or neutralizing enzymes, right? That's what it's doing. It's very biochemical in nature. You'll see that it looks like a cherry blossom tree. I always feel like it looks like a cherry blossom tree, like when the blossoms are out. And so it has these very thick fibers, actually, like trunks of the tree kind of fibers. And then all of these little like teeny tiny cells here, they kind of look like the leaves of the tree to me, okay? So they are less structured, so they're relatively looser, for sure. So the point of all of the fibers is they actually still form a shape, but it's not a hard shape. It's a general floppy filter organ level shape, right? It's not quite the skeleton. It's not quite free flowing, so that's what it's generally doing. So what we're doing is we're able to support cells and a different filtrate from kind of going through and in and out and all that good stuff. Okay. So that's this one. These I think are a lot easier because it looks like what it's doing. I mean, I feel like when I look at connective tissues and like proper, they just look like, gosh, I can't even believe it. It's perfect. Here is a piece of pink lab tape. It's pretty much looking like the same thing, right? We're just connecting stuff. In this case, we're connecting, say a tendon would be a muscle to bone connection, and then like a ligament is a bone to bone connection in general, right? And so the body does this thing where it makes a lot of these fibers here. These are, remember we talked about collagens like the rebar, really, really strong? You kind of need it to be strong for that, right? And so then you have these squished little like muscles, or not muscles, not squished muscles, you have nuclei. I was thinking of the muscles because of the tendon, sorry. These little squished nuclei, so they're like not really manufacturing a whole lot right now, right? They made collagen in abundance. If you do things, because there's not a lot of like matrix, so there's not a lot of, this is like low vascularization, okay? The blood is not really getting in here super well. So like if you tear a tendon or a ligament, it's gonna take many times longer to heal than even breaking a bone. Just mainly because that supportive connective tissue, the blood can't get in there and like help activate some of these tissues. So it takes a little bit longer, right? So this one's just meant to like lay down and stay down, okay? So that's one of the proper connective tissues. This one, people always say it looks like a psychedelic hippie poster. Like if you had a band and it was like from that particular genre, this might be the background of like the band picture, right? Like this would be the picture. And so what this is kind of interesting. It's another type of connective tissue proper, but like the other one, right? Like the tendons and the ligaments, they're strong workers and they're doing like directional motion, like this way and that way, two directions. This one is swirly whirly because it's meant to rotate in multiple directions, right? So it's meant to allow for these movements, okay? And so in this case, it's showing it's holding over the synovial joint, right? Which means like it's going to be able to have fluid in it because it has to move in many, many different directions. All of the directional pull can come from any direction because of that. Does that make sense? Yeah, not a lot of nuclei again. Not a lot of like, the fibers are actually all of these, they're just so dense. Another one that if you rip it, it's really hard to repair. You can, but it's not great. Okay, good. Okay, this one, now this is very different. This is another connective tissue proper, but like remember we talked about how like collagen's the rebar? Elastic is the flexibility, it's the bounce spring, okay? These are elastic fibers, and you can like see the ripple, right? You can see the like, it's gonna bounce. It can get big and it can get small, okay? It allows for that recoil. So in this case, we're looking for in the heart, right, large arteries. So when we're dealing with blood pressures, we can accommodate it without it tearing open, basically, right? Like what if you were just kind of resting and you're like, oh my gosh, I gotta get the run done. And then you go and your heart rate's up and then you don't have that accommodation, right? And you don't want an aneurysm just for that. And so like, in this case, that flexibility is important, right? This is another reason why it's important to just like kind of have those clean arteries, like diet low in animal fat. And I know I love to eat animal fat so much, butter, butter, butter. But when you line these, they don't survive well, okay? And they become scarred and then they lose the flexibility, and that is when you get tears. Because it suffocates them and they die from those plaques. So just, that's like a million classes away from now, but, just